Okay, and should be back. Make sure I get the right chat window open. Cool. So I just had some lunch, and right before going to lunch, I did a quick check, and I found out why it wasn't working. It is supposed to turn on power domains for devices before probing them, but it only works for one power domain because it turns out that you can only attach one power domain to a device object in the kernel. So devices that have more than one power domain have to manage it manually, basically through an extra API. So what I'm going to do instead is actually change the dependency tree here because it makes sense for ANS2 to depend on the storage PCIe device. And then that can just be the power domain for these things. So if I'm right, this should be all I need to make it work. Let's reboot. And also, let's see what happened with the checks. Oh, was that actually... I don't remember if I actually ran it. Yeah, all the checks. Did it fail? No, it passed. Okay, I think that's fine then. Let's see, warnings. Cool, okay, so the bindings also work. So that's looking good. And then the other thing I realized is that the reset support is going to be very useful for these ASCs because, yay, there we go. Yep, it works. Cool. So for now, we're just going to do it like this. And if we figure out that there's a good reason to manage the power states of those two domains separately, then the ANS driver can grow support for that and, whatever. But this makes sense to me and this works and it's simple. So we're going to go with that. So, valid namespace 0. Cool. So yeah, I'm thinking I might want to try the reset thing. Just to prove that it works, even though we may not use it. But it would be interesting because, for example, it means that I could initialize ANS2 in Mini once, and then Linux would still work, right? So let's see. Let's see first if I can break this real quick. ANS2. We need start. We don't have start, but I probably can just break it anyway by just trying to initialize it from Mini. So let's do a reboot. Do we have anything for ANS here? No, we have just trace. Let's just do a real quick thing. Instantiate ANS2 as a... and I do need the pmanager thing here. Basically, I'm going to break Linux, and then I'm going to fix it by implementing resets, which I think makes a lot of sense. So let's get Mini set up. And then the p states old had all the pmanager stuff. Yeah, PMP. So basically... but what was the generic thing? I had an SMC somewhere, but not here. What was I using SMC for? I had it for something, and I forgot what it was for. Anyway. So let's go to, if I remember how to do this, firmware, ASC, init. I just need an standard ASC, which should be enough. And adder, and adder. We don't have a Dart. I have a start, which is not implemented, but we'll live with that. Yep, ANS is the NVMe interface thing. So I just want to initialize it at least part of the way, just because that will break Linux initializing it, and then I want to prove to myself that I can use the reset bits to fix that. So in principle, if I just do ans.boot, that should probably do the right thing. If I got that right, let's see. I probably didn't get that right. Just close this. I don't need a UART for anything right now. And I forgot what the hotkey was for that. Whatever. Just kill it. I have too many of these windows open. Let me just close this one because otherwise it's confusing. The firmware should stay because the firmware is in main RAM. It's not in the coprocessor. The firmware is loaded by the bootloader, and there's no reason why it would go away. Also, I need to turn it on. Sorry, I forgot about that. I need the P manager, not the hardware P manager, just the I forgot how to do that. Proxy client many proxy, not proxy utils, proxy. Yeah, P manager clock enable or something. ADT clocks enabled. Yeah, that. What was that about? So yeah, I need the. I think that might work. Let's see if it works. PMP is not defined. Yes, because it's not PMP. It's ASC. But the clock's enable. Oh, we're getting ARM IO. Sorry, ARM dash IO slash ans. See if that works at least. Yes, looks like it. Cool. And then I want to get the from mini dot firmware ASC import standard ASC. Just do it like that and see if that works. Yeah, it crashed. Which is exactly what I expected because we're not using the right. Oh no, it didn't crash. Sorry, it. I think it actually initialized properly. That's just the buffer. And it just hangs waiting for something. Wait, boot. Yeah, it probably just like crashed while trying to write a crash dump or something like that, which is fine. The point is I want to crash it. And the point, as you'll see, is that so if I run this once, right, it breaks. And then if I run it again, it doesn't work at all because it's already enabled and broken. So now what I want to know is whether I can actually reset it by poking that register. Dump P manager. So we got this. So the register for ANS is somewhere here. If I can find it. Script. This one. It should be this register, which is turned on now, as you expect. It has that bit set. I forgot what that bit was. What was that thing? P manager should be bit 13. Oh yeah, we don't know what that is. We don't know what that bit is. So it'd be nice to find that out, but whatever. So let's see if I can reset it. Set and clear it, and let's just run the let's test again. P dot set 32, of course. I am doing this backwards. I copied the value, not the address. Okay, let's do that, and it does not work. In fact, I got pretty confused. Let's see what we have. It might be that I broke something, but I doing this reset like this. Manager ES2 state. Like this before, like this after. So I just reboot it. Let's see if it works resetting it. Yes. So if I reset it and unreset it, it does work. I run it again. It does not work. And that crashed somehow. Doing what? Oh, no, it's just on boot. Not sure why it does that. But okay. So what's a good way of doing this? Maybe that reset bit doesn't work on ASCs. Hex, please. And also, if I don't unreset it, it should definitely not work. Yeah, it definitely got stuck somewhere. Probably not even the first register right worked on that. Let's clear that. So let me do another thing then. Let's get a shell and do a mon.add of ans2, which should be at u.att, ans. Yes, it only changes a single bit, otherwise it'd be right. Yeah, so add all that. Oh yeah, it's off right now, which is what you expect. So if I turn it on, then it should not do that anymore, and we get a lot of stuff as you expect. And abort it on what? 08. Yeah, it still gets exceptions. 277468008. Probably there's holes in the map for that. Yeah, that's too much. Is that a thing? No. Mon dot. Like that. And that was faulting. It's 7746808. So pretty far in, actually. 68. Yeah, that works. And then if I do the set, and then it crashes accessing the registers. Of course it does. So let's do. Hold on. Let's do pmanager that first. Mon add, that just works. And then if I okay, something changed into I didn't actually do anything. It's interesting. Yeah, some things are changing there. Maybe each read changes something on those. Those look like read sensitive registers, actually, kind of. I'm not sure what's going on there. But what I want to do is, if I do this and then clear it immediately afterwards, then at least it shouldn't crash. Or it does. Interesting. So does that break it? Or does APCIe storage really depend on the other thing? Yeah, so that... It does claim to depend on... I think that changed, but APCIe storage was the one that we had, I think. Yeah. So what if I do that one? What if I do 418? Well, this did work, though, with the states. Yeah, it doesn't work if I do that. Let me check to see if we get any dependencies like noted here. Pull, and then do a pull. It's just that one thing, right? Wait, hold on, what? Oh, yeah, there you go. That's unclears. So if I don't do that here and shall add that, dump p manager. Actually, I wonder if just turning it off and on would work. Because it is supposed, this one is supposed to do actually power gate, I think. So let's see what happens if I just change that. No. But that only clock gated it, which I can see from that bit. Yeah. Wait, it's 418 what I think it is? No, I have 3 if 0, so that's supposed to be. Oh, okay, that does work. Okay, so power gating it actually does work. And you can see that like a bunch of registers randomly change. That's interesting though, because it means that power gating it does actually make it rebootable, but not. And that should also have set that flag. Yes, the 3. See the means it was power gated. But then why does reset not work? Why is that not sufficient? And also another important thing is that when I power gate that, if I do this and then pull in between, I want to see if anything else changes in vManager. I don't think so though. No, see, it just gets gated. So that's kind of annoying. I was hoping that reset would work, but apparently it doesn't. Yeah, it doesn't. Let's get there anyway. It like totally crashed actually. Wait, was that 2 there before? Yeah, it was. Maybe this device doesn't like being reset. Will the final version of Asahi Linux be installed like Arch Linux or a GUI installer? Neither actually. It will at least initially be a console installer, but like a still like a next like sort of guided installer thing. The idea is that we're going to give people a script that you can run from macOS to install whatever distro you want. One of them is going to be our version of Arch Linux, and I'm going to have images that have like a GUI pre-installed and stuff like that, so that like people who just want like a desktop OS don't have to install everything manually. Yeah, I'm not working on a graphical installer. That's something that is up for grabs if someone wants to start working on like a Mac OS, Cocoa or whatever installer. That's up for grabs. But what I have done is a text-based installer, which is basically it's basically a proof of concept now, but it will evolve into something a little bit more user friendly. And it's basically it just asks you questions on the console, and you type enter and whatever you want to do, and and do it. So it's not a, it's still an installer. It's just not graphical. So it actually crashes accessing the register, which is kind of annoying. Yeah, it like actually dies, which is pretty sad. Oh, is it because I need to? Do I need to set that thing with the no access, the like dev disable thing that if I do it like that, if this works, then that is a aha! That does work. Excellent. So if I do that like that, it doesn't work. Interesting. Okay, so that tells me that if I'm that it's important because I just fixed something in the Linux driver. That means that if I want to do a reset, I better set this bit first, otherwise bad things might happen. And actually, I think I might know what the problem is. I think the problem might be that I'm resetting ANS while it's doing DMA or something like that, or trying to, and so that breaks something about the bus fabric. And so you need to guard it. So this is important information because I definitely need to do this in my reset driver. And then this is working as intended now. Excellent. I can do ANS test as many times as I want without a power gate, and it's correctly resetting. Cool. Okay, so problem solved, and I learned something new, and that needs to go in the driver. So that means here dev disable. When we do a reset assert, we need to dev disable. Actually, you know what? I'm not even checking any of those reg map return values anyway, so this is kind of pointless. Like if these calls don't work, then something has gone horribly wrong. Don't really need any of that. Sven, yes, he couldn't figure out how to reset ANS. Well, I just did. But yeah, I think this makes a lot of sense. Like I reset the UART without dev disable, and that worked fine. And that's probably because it's a dumb peripheral with no DMA. But probably for things that do DMA, if you don't do the dev disable thing first, it breaks in horrible ways. So that so what I want to do, and actually, is I don't know if you want to do this, Sven, because I have other drivers to write anyway. But since I wrote the reset driver, that's completely untested though. Like, are you interested in adding this to the ANS driver so you can do like build it as a module and be able to like reload it, and it'll reboot every time or something like that? Like ideally, it would reset ANS on startup. Also, I did a quick look at the at how the reset stuff works, and like you can share a reset line between multiple peripherals like SART and ANS. And it's set up in such a way that only the first peripheral to issue a reset pulse when you use the reset function actually resets it. So I think the idea is that you issue a reset at the beginning of the probe function on both drivers, and then the first one to hit it is the one that actually resets it. I don't know if it rearms automatically if you unbind all the drivers. I would hope it does. If it doesn't, it probably should. Um, yeah. Since it's not just DMA, it must be more. I mean, I'm saying DMA, but what I mean is like the bus master interface might be doing something, right? Like even if it's even if the device itself is not actually issuing transactions, it could still be. It's going to do things like cache snooping or whatever. It's going to participate as a bus master, right? So it's entirely possible that if you don't set that bit, then that works. Like for devices that can do DMA, even if they're not doing it. So yeah, I think what I'm going to do is I'm going to leave this to Sven. Once I can just push this real quick to test branch. Is there any to wait after saying dev disable? I don't know. We can try it. We can test it actually. Let's go to here and let's do it back to back and see if it actually. Let's just do it totally back to back and see what happens. Let's do a like super fast reset and see if that works. And then instead of doing we don't need these polls and these things anymore. Read it and then do p.call util dot set, and then just do that again. Manager ans2 is not defined. Did I just delete that? Yes. And also I need to pass it as an argument. Okay, that works. Okay, it seems to work. So, and of course, if I don't set that bit, then that won't do the reset properly. Or oh, interesting. 0 is not a valid argument for or apparently. Okay. Yeah. See, that doesn't boot. So apparently, we don't actually need to wait any time for resets, at least for this peripheral, anyway. In fact, does this work if I do that at the same time? It might even. No, see, that doesn't work. So they definitely need to happen at least as separate writes, for sure. But apparently we don't need to wait, so... Yeah, does resetting DCP unlock the Dart? I was wondering about that. And we don't want to do that because it will break like continuity of the graphics. But I was wondering if that was a thing. Let me do a quick test on the shell. But yeah, I think we're just going to say that these synchronous resets. I'm gonna say just in case some peripherals actually need more of a reset. I was gonna say 1 microsecond, but the def disable definitely doesn't need anything. So I think we're good on that. If Mini did it, would it matter? That's a good point. If Mini did it, it might not matter. But the other question is whether we can actually reinitialize DCP properly without like the iBoot interface, which is different. I'm not sure how that works. But you'd think it would. Like, I want to be able to reset DCP anyway, just because developing the DCP driver and graphics and everything, I don't want to reboot Linux every time. So once you get to that level, like, it makes sense to just be able to do, like develop on device and load modules and stuff. Okay, let's do a quick test. Let's see if I can reset DCP and see what happens. So let's do shell and ADT. So we have that, and then P manager. Oh, it's actually DISP, right? It's not DCP. Oh, but DISP is CPU. Hopefully, it's DCP. Let's find out. So it should be easy to take Dart DCP. So if I just read that, that works. And then if I do zero CPU. Hopefully this one. Not the value. This one. So if I do set 32 of 1, is it 10? Where am I? Yes, test. Yes. If I read that now, okay, that. So this is interesting right now because I just blocked DCP from accessing anything, but like the frame buffer still works, which means this is interesting because it might mean because DCP can hand off from itself, right? Because we can iBoot reloads DCP firmware, so it's actually possible that we can do this without any blinks. So if now I reset it, and the frame buffer still works because that's the display controller, right? DCP, it's not going to break the display. Now I unreset it, and I give it access. Okay. What's the lock bit? So for example, if you have a TCR at at 100, a TTBR, let's say. That looks yeah, it doesn't. So that does not work. It's still locked. I wonder if the reset just doesn't work on DCP. Like if I do just the reset. Oh no, that doesn't break it at least. This is assuming it's that peripheral though, which it might not be. It might be a different one. This thing, this 0. We have a lot of things here, right? CPU B, GP1, GP0. But it has to be CPU, right? I mean, CPU is definitely controlling the. So what if I hold on? So let me try. If I set, actually, let's just read first. Okay, so that power gated DCP in theory. And that definitely doesn't like me doing that. So if I... No, but it's still there. Yeah. Now the question, though, the interesting question is whether... I mean, the Dart's still locked fine, but experiments DCP PY. Does this still work? No. And it's doing starting via message. So what if I experiments DCP.py? What if I do a boot instead? Okay, that doesn't work either. So what if I actually do a proper reset here? Just put it in a block, like this. This one should be P manager 0 CPU 0 should be this one. Okay, that doesn't it doesn't like me just booting it like that. Or maybe it needs boot and the message. No. It's just waiting for stuff, which doesn't work. Oh, wait, hold on. If I need, not boot, sorry. If I am in ANS trace, ASC, not trace, hardware, firmware, ASC init. Not .boot, but super boot is what I need, actually, which is kind of annoying now. Let's just see if that does anything for DCP. Because it might. Nah. Does it work on a cold? No. Actually, think about the dependencies for a second. You'd think that but nothing depends on CPU 0, though, in principle. Yeah, nothing does. Okay, let me just make sure that first that actually works. DCP. I think that should work, because I don't think there's anything here in hardware ESC. I think it just sets the bit. It clears it too, but that shouldn't matter. Yeah, okay, so that does work. Also, apparently, something's broken here. Probably running a, like, I updated and that broke something in DCP. So boot start does work. So if I true this, if I just do the access thing, does that work? Yeah, that does work. And if I actually reset it, that does not work. Yeah, so the thing is, we don't know how the iBoot interface works, though. So it's possible that we need to use a different interface to talk to DCP first. And then only after that will it accept the normal, the normal thing. Actually, I had some notes on that on the tracer. Where was I? I had some notes on the iBoot things somewhere, but I forget where. Here, yeah. It says set resource. Yeah, there's no like exit thing, right? It might be a different level of commands, though. Anyway, I do want to figure out how to make this work, but it's going to need a bit more. It might need the reverse engineering of the DCP firmware. That wouldn't be surprising. Also, hold on, let me try something. No, that doesn't work either. An ANS test does work like that. And just to make sure, can I do this the other way around? Like, yeah, probably doesn't matter which order you unset those bits. Yeah, of course, that doesn't work. But probably needs to be like this to be safe. Yeah. Anyway, at least for ANS, this works. So I'm going to leave it to Sven to implement this in the ANS stuff so that we can test that the reset code works on Linux. And I'm going to go for the CPU frequency driver, which is the next part. So let me just do a quick add of this thing here. Oh yeah, I also need to fix those. I'm probably just gonna squash all this anyway. Mm. Yeah, no, this is gonna do the rebase like this, isn't it? Hold on. It's the same way of doing this. Just cherry pick those two things on top. Yeah, probably got something. Yeah. This thing. Yeah, I'll go with that. And then the other one was this one. Slash. That can just be a fix. Wait, didn't I just... Oh, I forgot to add the... Yes, to... Yeah, I forgot to add that. Hold on. Just do it like that. A bit of a noise there. Apparently that was noise anyway. Log. And then merging. This is going to be annoying. Hey, Sven, what's your latest NVMe branch? Because I might as well just make this merge work properly now. Not sure if he's listening or not. Yeah, that has a lot of stuff, right? Yeah, we have so many people working on everything that is like, and everything's connected to everything else, that this is getting pretty messy. Which is why I want to send these for review soon, so that, and then do my own merge so that people have a reasonable base to work off of. Okay, I'm just going to then push this pmanager thing to pmanager dev. NVMe new is fine for now. Okay. And this has hard drivers, DTS nodes, RTKit stuff, bindings, and no pmanager stuff in here, as I understand. It's just so that you have something to work off of. So I'll just merge this for now, and you can do whatever you want. Yeah, I forgot. Because I did the reset the stupid way. These two things too. Okay. Just gonna fix the conflicts. That should be like that. And then this merge that I already did earlier anyway. Oh yeah, Sven, let's make sure that we have the GPL or MIT licenses on everything that isn't, like significantly based on something else that isn't, including the kconfig files and everything, because Okay, that should be enough of that. And this should also be, that is set to that, yeah. Okay, so let me just make sure this actually works. Oh, there's an unused variable. Yeah, I forgot that one. That did not work. Hold on. Is it just because I didn't I hadn't reset ANS? Probably. Is the CPU freak driver just an interface for the scheduler, government notification, core speeds, or is it more involved in that? It's actually just a power management driver that has. Oops. I think I've got something wrong in the DTS. Oh, I didn't add it yet. Is why I need to actually add it. It's just it's the same thing as the PS driver, except it's going to have different power levels basically, and so then there is an actual CPU freak driver that is generic that will just use that. I think that worked. Yeah, that looks good to me. Awesome. So yeah, let me just commit that. Okay. Would be nice to. I don't even know if you can do that with Git. Like, can you like rebase a merge commit into something else? I'm not sure if that actually works. But it doesn't really matter. So I'm just going to push this to. push it to there. Or not. Hmm. Guess it needs it like that. And then pmanager work. And then get this. Dev. Just take that from there. Okay, I think that works. So yes, when I left it for you on pmanager and vme merge, if you want to play around with that. Ideally, you can add the reset client to the NVMe and start and just do a reset at the top of the probe function, and that should allow you to reload the to reprobe the devices multiple times, basically, if it works properly. And it should let you do it if you initialize it in Mini. So, CPU freak. Let me actually, I'm gonna get some water. So, might as well leave this on top of manager work and then just separate the patches out. So let's see. CPU frequencies. What we need is a driver that is similar to this one. I can copy and paste the scaffolding. But oh yeah, I need to define debug there. So a bunch of things need to be cleaned up anyway. But let's see. So the main thing is here in GenPD. This OPP stuff in here, right? Translate performance state, all this stuff. So there should be some CPU freak drivers we can look at. Some OPP stuff. Document. So actually, Arch, ARM64 boot, DTS. Yeah. So this should work. And yeah, 399 DTSI. This is also something that needs to be written. I need to write a CPU idle driver, but that's a bit less important. We already have partial idle stage, just not the deepest it can go. So how are these CPU freak things called here? Okay, I'm not sure how this one's doing it actually. It might just use a PSDI thing. Is there a rock chip thing here? No. Um. Yeah, DT. Oh, DT plat dev. Is this a? Yeah, yeah. I know how the OPP binding works, but I'm trying to figure out how the actual driver binds to this. Yeah, it's a CPU reflect DT, which is what I thought. So if it has OPP nodes, it uses that, and then how does it get the? It's just def PM. Let me look at a different CPU in case, because it might be that that it's in it. It's one of these sub devices that actually configures the regulators. It might be. Ah, this might be it actually. CPU supply. Oh, is it just using like the regulators and then the clock for the setting? It might. It might just be doing that. CPU frag DT. The CPU frag DT. Ah, yeah. So it uses a clock, and Does it work without a supply? No, it looks like it works without that. So maybe all I need is a clock. Okay, so then once it actually gets to the uh, set target. Oh, it just says def PM OPP set rate. So it's using the OPP layer for everything. Okay, so it just needs a clock then. Yeah, it's about DVFS, but like it does a lot of the scaffolding for us for the making the CPU shared and all that. So I'm thinking I can just implement the cluster P state driver as a clock controller. The only annoying thing is that like instead of indexed P states, then it has to go through the OPP table, which is going to use frequencies. But that sounds like it's probably going to work. Well, no, the thing is the clock layer is going to get a frequency, so the clock layer needs to look at the OPP table itself and backwards find the index. There is, if I remember correctly, there is documentation. There is a thing already in the binding we can use. The sorry, OPPv2 is where? Where's v2? Is it here? Yeah. There was a thing. OPP level. So OPP, we can use OPP level to describe the P state. It's just an annoying lookup in the clock driver because it's going to get a clock frequency, not an index. But I think that makes sense. And then I just have to implement a clock driver, which is pretty easy. So where should this go? Probably there's clock, I guess. Clock 8 went away, but let's do clock. Clock 8 might work. This one. Let's just make one from scratch. Look. Yeah, let's just call it clock apple cluster piece today, I guess. Okay, so let's. We had this. Oh, look, it's still in my thing. So let's just put this in here. Apple Power Manager piece state. We'll just copy some of this. Sven, I'm allowed to remove your name, right? And basically, this is going to change, so it actually does the performance state thing. So that. No reg mag, no offset. And then most of this is going to go away. And this is going no reg maps here. It's going to do a proper IO map thing, so. There we go. Oh yeah, that went away. I just find the random. So this is gun node. No parents. We need to clock init data. And it's not gate, it's cluster. So cluster, what is cluster HW? No parents for this, as far as I know. That should be most of that. And just the I need to IO map those things. Yeah, that'll work. What was the thing, devm? It was just that. Yeah, that's what I was saying. Don't have resource. That's what I was. Yeah, thank you. That's what I was looking for. Init, okay, cluster. And that should be an IO mem. Cluster. Just if it's there. Okay, it should be that. So, and now the page state stuff, which is coming from this Python script, but basically, was this the same? Well, yeah, the ADT has some weird stuff for the clusters, I think. Hold on. What is NP manager? Yeah, all that mess here, but basically, the P, yeah, so it starts at 2, and then has a whole bunch of very strange register names. Probably only 2 because the only things we have to touch are all in 2 something. Everything else seems like we don't need to touch it. So yeah. So let's declare it like that, and um, I still wonder though what to do about that memory controller thing. Should it be a separate driver? The thing is, we don't even have a same way for presenting that in OPP because it's not even. It's not even. They don't even have it like the. It's not really a. It's not really a frequency, right, or anything like that. So anyway, please state. So let's just say that it's at 2000. So the P state would just be here. cluster. Thing is, I don't even know if that's DVMR because it enables DVMR is the middle bits, right? So I might want to just call it like config or something like that. 3, 32, and 31. Let's go enable or something. Uh, I do wonder about why there are two values for the p state, though. Actually, let me do a quick test with Mini. See what happens if I set them differently. Does it only use one or what? Chain load. Oh yeah. Not after initializing SMP. Yeah, it's to that. So if I set this to like 1. Oh, interesting. Oh, yeah, it's only setting it in the top cluster. So that does go to the lowest. And if I do it like that, yeah, it looks like it basically only listens to the low bits anyway. So I don't know what this is about. Yeah, it could be min max, but I don't think it's target actual because it actually lets you set both, I think. Yeah, see, like it actually does let you like set both, so it might be another bit for like min max or something like that. Oh yeah, and there was also a bit for whether it's complete or busy or something. Apparently that bit can be turned off. It doesn't matter. Yeah, this is just PS1. And also those bits, let's see. Those bits mostly don't do anything. Most of the bits are unimplemented, so. Yeah. Oh, that's actually not doing anything now. Yeah, it's ignoring me now. Okay, that worked. Something there makes it not actually change the speed state on one of those bits. That works. That works. Sorry, 4. That bit, yeah, that bit does something about it not switching speed states. Might be a disable or something. That does work. Um, yeah, that works. Yeah, so I don't know what the top P state setting is for. If there is a like an automatic configure thing, it's probably in a different register or something. So. Let me look at the. I know Cordian was checking a bit for like whether it was busy or not, so that's something that I need to see. Actually, let me do it. Let's do it like this. Actually, let's see if it actually. Uh, 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 Actually, wasn't that a thing already in the Roxy? Didn't we have a write read thing? Yeah, we had a write read. Helps if I do this. Aha, you can see. Oh, look. So there's a bit there. That's like a busy bit or something. Clearly. And what bit is that? That's bit 31, right? Yep. Yeah, so the way what macOS writes is this, which is just that bit, right? The set bit, yeah. And then the piece that in both those places. So we can probably just do it like that. Okay, so the question now is, how do we set these clock ops to make it work with OPP? And I should be able to look at that rock chip driver and see what happens. Um, That's a lot of stuff there we don't need, but basically just see how it handles the ops. This is not there. Because there's like a whole bunch of sub things. Arm clock, right? That's the yeah, that kind of thing. One second, toilet. Okay, let's see. Oh, it's in like no. Yeah. There's a lot of stuff on this thing. Yeah, so you can do the rate table thing, right? And that's basically the same thing. Anyway, the ops are where? Just recalculate? That doesn't make much sense. Oh, because it's using the parenting thing. Okay, yeah, so this is overcomplicated. It's just fine. I think we can just get away with something simple. Let's look at the clock ops. Probably get away with just set rate. So let's just call it on that. And I need one of those things. So let's get a kconfig here. I never understand if like things in these menus are actually sorted in any way. Or and like, why is it common clock for some and clock for another? And like, why does this not have tabs? And I guess it should be common clock, but ah. See, these are sorted. Actually, this should probably be just Apple cluster. Call it like that. Can you use bools in the kernel these days? I think so, yeah. That's annoying. Yes. That was DVFS. That's what was that called? DVMR. And then I need to check for a property on this thing, like the way I did on clock measure power state. Okay. And then basically what I need to do is just do that. These are 64 bits. Okay, a bunch of includes we're missing here. Don't need syscon, don't need rec map, do need platform device. I don't think we need OF address. We do need OF and clock provider. Okay. No return sensor, yes. And then those are IO, whatever those things are. Linux IO is what it is. Let's sort these by maybe module. No, this probably shouldn't be a module. Should it? Yeah, maybe it should. Okay. Semicolon. Okay, that compiles. So I wonder if that's enough to get the rest of the framework to do what I want. So let's put things into the device tree. So this is where it gets fun. It's gonna be the same as those rock chips. Arch ARM64 boot, DTS, rock chip, 399.dtsi, but also the OPP. Okay, so latency is thing again. That's all the info we need for this. We're not going to declare the 0 one. Nine 7 2 1 3 3 2 1704 and 2064. And we do have the voltages in the ADT. That is completely unnecessary, but might as well add them. Yeah, these voltage states 0, blue, whatever. 9 here. These are the ones that matter. 1 SRAM. This should be these. Uh, 684. 628. And 559. That should be it for the P cores. And now the E cores, and now the P cores. Yeah, it should be these. Just copy and paste it here and funny, those are like very similar. Six. I think that's all of them. Yep. And now the voltages. Does it have to be 3? 1 or 3, okay. Yeah, let's not bother with this min-max nonsense. Because we're not actually using this anyway. This is optional, though. We could just remove it, actually. But, chat might ask if overclocking would be simple as marking the operating points. Yes, but not here. I don't know if it's locked though. So the thing is, we're not actually setting these values directly. The hardware takes care of this. This is just so Linux knows what the frequencies are. So, however, I'm pretty sure there are registers that you can use to modify what these operating points are, but they're not the ones we're using now. So, because the bootloader sets those up. So, if you want to experiment with that, feel free. Okay, and then the next thing is I need a OPP level thing because that's what I'm going to use for the. Okay, and now we need a CPU map for one, which is actually pretty similar to this one. Um, okay, should take care of that. And then we need clocks. Now we also need this the dBips megahertz thing. Has anyone benchmarked like the P course versus the E course to have a like a relative performance thing? Of course, it's going to vary by workload, but I'm just curious if anyone has done some benchmarks. So let's use this. Okay, and that's our clock. And so now under sock, we can declare a thing. It'll just be up here. That's clock controller, right? I think so. Cluster. And the addresses for these are here. Say we're going to start with 20s though. 210E0 to 2. Yeah, so like that. And we only really need like that much for now. Let's just do one page. Let's do 11E, cluster clock 0, yep. Let's see if that builds. Of course it doesn't build. 178. Semicolon or something? Yeah. Duplicate label clock E cluster. Did I copy and paste that wrong? E cluster. Okay, yeah, the other thing is the latencies, which I haven't set yet. So I want the clock latency NS. How many pieces has the cluster? The E cluster has 5. The P cluster has 15, plus the like 48 or 24 megahertz or whatever it was state that nothing uses. So the latencies, this stuff. So the maximum for going to 600 is basically let's round it up to that. And then the next one. We have it's kind of a wash for these, but let's say 8,000 for this one. And then these start getting there. So let's say 20, let's say 19, 21, 34 is 23 or something like that. Let's say 24. Let's say 23. It didn't matter that much anyway. Let's say 24 for this one. Okay, let me just run it again, see if I get similar numbers. Yeah, pretty much. 22, 250. 23, 4, 5, 8. Yeah, 24. Okay. 28, 29. 1956. 31. 34. 36. This close. This is 51. This would be 54-ish. 298 is 55 or something. And I think these are mostly constant. 3096 is also basically 55, and let's just say 56. Because the voltage is the same for these, so it should be the same amount of time to go to them, basically. Actually, they're basically all the same, I think. 12544 is it the same as before? Yes, it is a little bit higher for these, so we can say this. Yeah, there's a turbo mode thing, but I'm not sure what that does. It's not really what thing is. Linux isn't managing that though. The hardware is, so it's not really a turbo mode. It's kind of weird. And then yeah, this required OPPs is one way we can do the memory controller thing, but I need to think about what the best way of doing that is. But for now, this might work. Let's stick this in here. Did that just finish? Yeah. Okay. Okay, let's run it. As on the hypervisor. Let's see what happens. Ooh, that exploded because of the secondary. So I guess I did a reload. That's why. Okay. It just what? Didn't I cat? What? Is this too big? Too mangs? No, there's no way. Did I do something in the device tree that like libftt hates? What? Oh, rec property of CPU. Did I break something on the CPUs? Also, there's a missing new line there and failed to prepare FTT. Which is where? Payload, maybe? Yeah, there's a missing new line there. Oh, CPU map. Because it's seeing CPU map. It needs to. Yeah. It needs to only look at nodes that start at CPU at. What was the name thing? Yeah, that's the ticket name. Yeah, build that. Let's see if that works. Okay. 21 OT. Did I? That looks correct. Oh, I know what happened. I know what happened. What happened is I need where am I? Cluster. It's not right. Let's write Q. These are 64-bit registers. Okay, that runs. But the clock's failed to register clock. Probably because it wants like an init function or something. Minus 12 is what? Out of memory? What? Let's see about the clock stuff. Would it help to have a name? Might just be that. No, it should be initialized as 0 though. So oh no, yeah, but they'd be null because it'd be a startup of a null. That's why. Okay, now it's a 22. Round rate or determined rate, initial 3 calc rate. No, wait, you don't have recalculate either. Why is it saying? Okay, so it needs recalculate and round rate or determined rate. Okay. Or round rate. So what's different here? doesn't say anything. It's the field get keep forgetting how those things work. MIE chip. Yeah, field get field comma. Let's get desired one on that. So we're gonna have to get the p states on this later, but for now, let's just store the car p state. So let's get that recalculate stuff. Where's the header? We'll do the table thing later, but for now, just do that. And then we need round rate. And here we're just going to return rate for now. That's fine. Round rate needs to be long. Okay. Long int. Oh, that's just yeah. Okay, let's see if that does something. Okay, if failed the second one, probably because the clock is already. Okay, so let's do the C. I think we also don't have the CPU freak DT thing. So let's look for that. Yeah, it's not set. We should set that. Just turn on the governors, and then yeah, let's get everything. Default. Let's set it to on demand. See what happens. Let's do a schedule to this. Okay. Yes. And then I want to. Oh, is that not actually done? See, what is that flat dev thing? Let's just set it in here. In the config for. Okay, still failed with the second one. Yeah, that's the thing. Doesn't look like it did anything there. Okay, so let's just set the name to the device name. Is that a thing? Yeah, apparently. Okay, that doesn't break anymore. We definitely bound it. Um, okay, I think that it's not loading the DT driver. Oh, it needs both. Okay. Does it only need DT by any chance? Oh, I think it's both. Oh, okay, so it's the other way around. Okay. The driver's there, but it's not bound. So, CPU frac DT. CPU frac DT. Did I not set the OPPs for the CPUs? Might not have. Yeah, I didn't. Dumb. Usually CPU input does show the frequency, I believe. Semicolons. At least on Intel it does. I don't know if this is different, but okay. Not quite there. Oh, did I misspell it? Thank you. Aha! There we go. Now it's actually loaded. And the question is, does this actually do anything? Yeah, place C0, place C4. Stats. CPUs. Yep. Current frequency. Yep. That came from the driver. Clock, cluster. Yeah, so actually turn on debug. And so then the next part is just getting the OPP table. It doesn't know about those. I'm getting the debug though. Oh, it does. Okay, so it's just not showing in the console. Cool. So it does work. I think it's just that like my console isn't set to verbose or something. Yeah, I need to like pass debug or something. Where am I? Oh, because I reset this and so it doesn't. Yeah. Okay. Cool. So now the OPP table stuff. So the question is, I need to reference those tables from the clock here. But the question is, can I just do that? Probably. Just do it here. Should be able to just use this basically. So let's see if I can just use that function. And then I can just use find level exact. Hmm. How do I get the frequency? Ah, that. Oh, we do need error pointers on that. Then I need to just get level on that. Signed int. I guess we can just read the register anyway. Let's see if this builds. Is arrow pp arrow pointer? Pointer error. Now we don't do that anymore. Okay. And then there's a something cast to get freak 0. Wait, is it arrow pointer? Oh, it is, yeah. Okay, there we go. Cool. And so then for the actual setting of the register, is there 2? I don't know why there are 2 desired pre-states fields on the register. I was talking about that earlier. I have no idea. As far as I can tell, only this one is actually used. But macOS sets both, so I don't know. the right error for this. EIO probably. Actually, just do it like this. And then let's just take one of these things. Where was I? Here. Where is that declared? X delay. While before static. Okay. And now we just write it. Let's go like that. What happened here? Okay, let's see what happens. Cool. Get failed. Why did get fail? Mm, that's LX apparently. Okay. That did not work. Why? Oh, okay, that's important here. OBB tail not found. Hmm. Yeah, so this is basically. I think that's what I want. Aha. That's looking good. That's looking pretty good. I like that. I guess the frequencies aren't in CPU info on ARM. Nice. So what if I... Oh, that didn't do the CPU frequencies in the end, or am I just not doing it? Trace. I thought I was tracing that. Yeah, it should. Hmm. Okay, no, it does work. I think the trace was broken for some reason. Weird. Cool. That's the index of the performance state. Okay, and then the last thing is we should have that that thing with the capacity DMIPS megahertz thing, because we don't know. Because otherwise the scheduler doesn't know anything about what. So let's just do the same thing they did with 1024 on these. And then we need to figure out how fast the E-cores are. Okay, I'm gonna turn off that because that debug is definitely not useful. Um, mm, 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 mm. I guess I can just turn on the debug stuff. Let's see. Looks like about twice as fast on the dumbest benchmark ever, but let's go with that for now. Um, just to be more precise. 47, 454. I'm sure someone can come up with a better estimate than this, but for now this should do the right thing. At least it tells the scheduler that we want to put things on those cores. Oh wait, no, that's not the missed megahertz because the frequencies are different. I need to scale by the frequencies, which are, so it'd be like, sorry about that. 454 is the relative capacity at the maximum frequency, but we know we're not reaching. We know we're not reaching this though. We know we're stuck at, I think it's 3096. It should be 3096. No, sorry, 298. So it should be 454. Yes, if it were running at 298, but it's actually running at 2064. Sorry, the other way around. So times 2064 divided by 298. No, the other way around, sorry. It's per megahertz, so it should be times 20, yeah. 2064. 657, okay. That doesn't quite sound right, but it's also probably because the benchmark I just did is nonsense. Do I have anything else more interesting that I can use to test this? We'll see. It looks too high, to be honest. But does anyone? Directly interface the spec into. There's definitely benchmarks we can use. I just want to know if anyone has done it already in a handy way. wonder if I can just get some. It's just a relative performance per frequency measure. Is there a Debian package for this? Or I can just build this on a random ARM64 somewhere. Let me see if I can do something. Uh, you can tell this code is from who knows when. Okay. Um, and then I want list. And then also I want this to mount stuff. So I keep forgetting about that. Hopefully that worked. Let's see. that just really hated me. Oh, that's how it works. Okay. That doesn't look right. That doesn't look right. Oh, I'm dumb. Okay, that's more like it. So, math. That should be at 2064. And then the other one should be at 1956. So pretty close, actually, because of the... no, not 1956. 2988. Cool. And then the relative performance is that... It's like pi. Okay. 326. And that makes sense because I seem to recall the P cores are quite a bit faster than the E cores. You can check my math if you want, but I think I did this right. Looks reasonable. It's per megahertz and then scale. Get the difference, and yeah, I think this is right. Okay, cool. And so now, if I just run this again with these numbers, hopefully if I run the benchmark, well, it was already the case before anyway. But basically, it should always be putting stuff on the big cores by default, especially once, you know. Let's get this stuff. Yep. Definitely getting straight to the... It looks like it puts them on the E cores very briefly or something sometimes. But it quickly speeds up the P cores. Cool. I would say that's a CPU frequency driver. Wasn't that bad. Yeah, the ratio is like close to pi. It's not exactly pi, but yeah, 200 lines of code, not bad. It's missing the memory thing though. But I think I can do that with the OPP like dependency stuff. And then of course I need a binding for this. No, this isn't the scaling. This is like the relative performance of performance core versus an efficiency core. It has to do with the microarchitecture. It's not about scaling or phase or anything. That's just a coincidence. So what's next? I should write the binding for this, so I can send it in. And think about the memory stuff. So how do I want to do that? The thing is, effectively, uh, I'd be writing a memory controller driver that just has like the two OPPs. The thing is, it's not a frequency though. Probably just have levels. So let's try that. Let's try doing that memory controller thing. Basically, it's the same thing the ADT had on there. Let me just write that first. What was that thing? C or something? No. What was it, memory? DCS. Yeah, they call it MCC. Do you have a thing for like memory controllers? Yeah, something. Oh, it's like EDAC stuff. But still, though. Let's see how that calls it. Yeah, this is memory controller. And then in CPOP states, we had that thing. And actually, these should be sorted. I think we said we were going to sort these by address, because otherwise it becomes a bit of a mess. And so then I can use the other documentation, power, OPP. device tree bindings OPP. Yeah, these called it. Yeah, so basically required OPPs. And those get run at, which ones was it? 2184. So starting at 2184, which is here. Something like that. Okay, so let's see about this. How big is that? Thanks. Okay, and now Where does that even go? Sock? It's not EDAC though. Those are just such as the bus. Driver's memory. Oh, there is a driver's memory. Okay. Okay. So now I go and just define the. Oh, so let's add this to the make file in the kconfig. All right. Let's take care of that. Apple and CC make file. Let me do an old config. That didn't do anything. It needs a memory on there. So that actually should be in Linux, Arch, ARM64, platforms, Apple. This should be doing select memory. Yeah. Probably. Or just, can I make it a default? Not sure. Probably just do it like that. Not sure. Is there anything else? No, nothing else is putting in memory there. It should be enough. Okay, so Apple MCC. Let's go look at the p-state thing again, and basically it's just it's just magic bits we don't know about. So we don't need the OPPs. We don't need cloud provider. We don't need BitOps. Not for this. So now, how do I make a device that self-manages its own OPPs? There has to be some way of doing that. I hope. Syntax there in the device tree. Semicolon. 326. No. Should be that, I think. What? Oh, yeah, I guess that needs to be like that. Okay. Yes. So back to the OPP. Surely there's a way of, oh, sorry. Surely there's a way of include Linux OPP. Maybe this one. Yeah, I think basically it'll just have to be that. So basically here, place all of that. No, that's the thing. Read U32. Uh, let's see. And num channels. And I think that's pretty much it. Um, so now I need to have a set OPP function. That's the prototype for that. And then it has an OPP data, and looking at the includes for this again. But that just uses the rate. How do I? Hmm. What we're gonna do is the OF get OF node thing, right? Which like nothing uses. There's one drive that uses that. Have I tried VS Code as an editor? No, but I'm pretty happy with Kate, so. Basically, once I have the OBP, this will work, but 32. Could perf config. And then get this here. And I want that E32 array. Oh, why am I doing this down here? Apple. Type. Put, and so delete all this. Basically, the channels are that big. I need to do the set driver data thing. Yeah, that. It's not like that. It's get driver data, and then you have MCC, none channels. Okay, and now the problem is, how do I get the this OVP thing? How do I go from the OPP request to OPP? This is a bit of a problem now. How does it work with what was that called? It should be an OF. Yeah, so it wants at least a VP level, which is fine. Well, it doesn't even do it. Okay, so the question now is there a way of managing getting the OPP from this? This might need some changes. I think this is going to need a change to the OPP API because, yeah, basically, there's only one user of this, right? Wait, there are 0 users of this? There's one DIOPP supply. So I might as well just change the API. It doesn't make any sense to only have frequencies there. More straightforward to combine both drivers? What do you mean? Old frequency, old OPPs. If I look at OPP here, so it really has a helper for returning the voltage. So I guess in that case, I'm going to keep these OPP info things and then just add that in there. And in that case, and then I can just go in my thing here, Apple, where am I? Memory. Actually, just level, which is an int, was it? Unsigned int. Not even level, sorry. Well, I want this the OF node, actually, sorry. Yeah, just get the OPP. This would be basically that. And also, this isn't a thing. Internal. Okay. Ah, yes. Okay, let's see if that works. Guess we don't need that. And pointer error. OPP. Okay. All right. Let's see what happens. Okay, that's not doing anything. Or it didn't go to the. No, it did go to the hype state and didn't trigger. Let's see. Let's see. Is that actually there? Yeah, it's in there. So the question is whether those. I probably need something in the cluster driver. Hmm. Uh, I see. Okay, let me just get rid of that. So it does the okay. Uh, yeah, there's no virt so just set required OPP. Okay, let me just delete that and see what happens. Okay. It does gen PD. Which obviously doesn't work in that case. Actually, let's see how I want to do this. The thing is, how can I get the devices using? Can I do a generic thing where I get the devices using a table? Yes, the thing is, like, it's a reference to a table, not a reference to a device, right? Uh, Do I want to do this record OVVs thing separately for the cluster driver? I mean, I could make the memory driver thing a Gen PD. Maybe that's the easiest way to do this. Maybe that is the way of doing to do this. Yeah. Either that or I just get the reference. Is there a way of getting like yeah, in principle I can just call def pm opp set opp. Yeah, maybe that's the way to go. So basically, because referencing the table and having it implicitly reference the devices feels weird. Um, so it makes more sense, I think, to just say something like that. But now I wonder about if we end up having multiple. I'm trying that's a single P cluster, but if we end up having multiple P clusters, then it might start making sense to use a GenPD, because then it would take care of like like minimum requirement logic and stuff like that. But we're not going to know that until like later this year. Hmm. What do I do? Do I make it a GenPD or? Hmm. Maybe I should. Okay, let's try the power domains approach and see what happens. So in this case, instead of that set up, it would be. Let's look at the other power domain thing I had. This thing. And in that case, it's basically. And then we do want a dev. Okay, so then the same as with the cluster thing, I need to get the calculate, find level exact. And it does use the level, I think. P state. Is it here? Base power domain, sorry. Oh, okay, it has a thing. Okay, should be enough of that. And then just return the level on that. It'll just be get level. Not clock gate. Okay, unused variable pp. Yeah. Let's see if that works. Memory is uncore or core sync. Memory is uncore, as far as I know. The thing is, like, this is like it's a weird thing with the memory, right? It's not actually changing the memory performance state because memory has like its own performance state management that I think is automated anyway. It's more like It's more like it's some kind of, I think, tweak like to the memory controller settings at the highest performance state. Uh, Apple. Need to start closing things. But it shouldn't have. It shouldn't be passing get clock. It's going through the Gen PD. Is it just because I'm doing this twice? Let's just try that like that. Oh, okay. That much, or at least didn't crash. What about the MCC? Maybe a stack trace here. So the app provider simple does PM up at table. And it's called by with add provider simple. Okay. That's in base power domain. Yeah, I just closed that. So in that case, let's do that manually. That should never happen, basically. Did I just kill the match table? I just did something weird there. Yeah. Okay. We already have dev. Should already have the OF node anyway. Yeah, shouldn't need that. Oh, is that not exported? Ah. That's not exported. Okay, so then again that doesn't work. So so in that case, think it doesn't matter if the clocks aren't there anyway. Like, it should just be a warning. I think. Okay, I'm getting the feeling that this is not quite what I want to do. Though, the question here is, how does the OPP thing deal with set performance state? Um, yeah, but it just calls it with the PDDef, which is not actually useful because it just sets the state unconditionally. It's not actually doing anything interesting. It's not like setting the highest perf state. Is it? No, it might be. Hold on. No, it does, I think. Ah, yeah. So this does do that. Okay, so then it makes sense to do it this way. In that case, I just need to fix that app provider simple thing. How do those wrap? 2 spaces. Oh, sorry, not this one. It's here. Okay, let's see what happens there. Why is that calling out the app provider simple? Oh, did I not call it yet? Yeah. Okay. Yeah, so the crash before wasn't that, it was something else. So now it's in at table indexed. Did the MCC actually initialize? Doesn't look like it actually. Oh no, it's rigging in no clock at table indexed. OPP to performance state. Huh. I should just be calling that on the GenPD, which is set. One second, toilet. Okay. That's like a stack address. How am I calling a stack address? Doesn't make any sense. You have a weird pointer somewhere or something? What? How is this in at table indexed and then LR is simply OPP to performance state? Let's just start doing this. Again, P is oh wait, I shouldn't be doing this again. I'm already calling that with fuck. Okay, it doesn't crash anymore. Now, what about those things actually switching though? Yeah, so it does initialize. What about the why is set required OPP is not getting called? No, it is going there. It's doing the switching thing, yeah. Then it does the scaling down thing, and then it does set required OPPs. They do it once. No. Actually, I'm tracing that, am I not? Or am I just being stupid? Uh, maybe it's just not going back because of the. So I'm only setting the state uh, for the higher state, but is it actually doing it? No. It does call set required OPPs. Mhm. Oh, okay. It takes the first OBP node only. Right. That's why it doesn't work. So it does want all of them to have that. Okay. Now it's failing. What is 19? Dev. Uh, and then why is PDDev CPU 4? Shouldn't be CPU 4. Oh, because it's because the OPPs are in the CPU, and then it's using. Okay. So it's not power domains here that needs to happen. It's in the CPUs. Let's try that. Why this die? Did I just crash my kernel? Like my host? What the hell happened here? Oh. No, it is at 1.4. Or maybe just my console. Oh no, it is working, okay. Let me just do that again. Ugh. Okay. Maybe it doesn't work with CPUs. Maybe this DMPD stuff isn't initialized for CPUs. Hmm. Hmm. Wait, why are there? Yeah, there's no children on it. There's no devices on it. So I guess this doesn't work for CPUs. Yeah, that doesn't make a lot of sense, does it? So how about instead of doing that, I put it in here and then manually set the performance state. Um, so in that case, if I basically just run this, PP, I just that like that. This needs to be no PP. It should be in there. PM Gen PD, yeah. Okay, get P state, invalid parameters. Get rid of that. Sorry, get rid of wait, I did already get rid of that. Hmm. It's because it still runs this part of the code, which is not what I want. Hmm. I'll just hack this in to see if that makes it work. Uh, okay, let me kill this. This window is getting weird. No device. Okay, not quite there. OPP table not found. Doesn't that just do that? Domain. Oh, yeah. Am I not saying the dev on that? Hey, cluster dev is not set. Duh. No, it is set. Uh, Wait, find level exact is being called by who? Get OF node? So this is actually calling into MCC at this point. Not here, MCC dev. Oh, that's not set. Okay, that's the problem. Okay. Maybe getting somewhere. That's fine. And then OBPT will not found. FMVP find level exact. That's because this isn't initializing the OPP table, is it? Well, it should be, though. this one does work. Cluster div. It's this high level exact. So this should be doing that. Oh, that's it to the gen PD. It's looking for the gen PD, not for the okay. That's why. So this should be that. Mm. Oh, I think it works. It's working. I think it's working. That's what the debug spew. It's doing the right thing. Right after it sets the first state to 8 or something large, sets the memory controller to high performance. Then when it set it to like 1, yep. Yeah. So also this is a mess, but I need to figure out if what I do about the CPU Gen PD stuff. Not here. Let me clean up some of the debug. I don't think we need that anymore. Let's turn that off too. Get rid of that. That's a hack. And try to run it again. Yeah, so it does work. It's just ooh. How does that happen? Oh, for the cluster that doesn't have the required PSA stuff. that should take care of that. And then the only problem is that, which let's just do that for now. I think it's working. Yep, it looks good. It gets at the hyperf when it goes there. Yep. Yep, looks good. Cool. Okay, I think that's good enough for today. I'm not sure if I'm totally happy with this solution, but I think I might just throw it at the mailing lists and see what people say about it. Um, so yeah, I think that's enough for today. It's midnight, and I should get some sleep. So I'll probably spend tomorrow doing the git cleanup story on this and sending things upstream. Let's see what they say. Okay. Thanks for watching, and I'll see you later.